All right, today we're going to crack open our devices and talk about one of the most common, but maybe misunderstood, numbers in all of tech, the clock rate.
You've seen these numbers, right? They're plastered all over the boxes for laptops, phones, you name it. And they're always screaming, hey, I'm fast, I'm powerful. But what are they actually measuring? What even is a gigahertz? And is a bigger number always better? Let's dive in.
So, at its very core, the clock rate, or clock speed, is basically the tempo for your processor. It's just a measure of how many pulses, or cycles, it can run through in 1 second. So 1 hertz is 1 cycle per second. 1 gigahertz, that's a billion cycles every single second. It's the fundamental heartbeat that keeps every single thing your computer does in perfect sync. Okay, so where does this ridiculously fast and precise beat actually come from? Well, it's not magic, it's pure physics. Believe it or not, inside every single processor, there's a tiny little slice of quartz crystal. And when you pass an electric current through it, this crystal oscillator vibrates at an incredibly specific and stable frequency. That vibration is what creates the clock signal, this perfect rhythmic pulse that the circuitry then turns into the on-off signal that runs our entire digital world. And the speed of that pulse, well, it has increased just dramatically over the years. I mean, look at this. The very first mechanical computer, the Z1, it just ticked along at a lazy 1 cycle per second. The original IBM PC in '81, it hit 4.77 million cycles a second. By the year 2000, AMD broke that incredible 1 billion cycle or gigahertz barrier. And today, processors like Intel's i9-14900KS can hit a wild 6.2 gigahertz right out of the box. But this brings up a really fascinating question. You see, manufacturers create thousands of processors that are supposed to be identical, all on a single silicon wafer. So why does one chip end up being sold as this top-tier, super expensive model, while its literal neighbor on the wafer gets sold as a cheaper, slower one? Well, the secret is in a process called binning. It's this standard industry practice for basically sorting and grading processors after they're made. So here's how it works. After a whole batch of chips is made, every single one is tested to find its maximum speed. Now, because of these tiny, just unavoidable imperfections in the silicon, some chips are just born better. The ones that can handle the highest frequencies without crashing get put in the top bin. People call this the silicon lottery, and those are sold as the premium products. The ones that are only stable at lower speeds, they get binned, labeled, and sold for a lower price. So yeah, that price difference you see at the store, it often comes down to these microscopic variations from the factory. Now, what's really interesting is that the speed the manufacturer puts on the box isn't always the absolute limit. And this is where things get fun, because users can actually take matters into their own hands. Tech enthusiasts can manually push their CPU's clock rate beyond the factory setting. That's a practice called overclocking. And they do it to squeeze out every last drop of performance. But the opposite is also true. You can underclock a processor, slowing it down on purpose to save power and reduce heat, which is something you see a lot in laptops and mobile devices. But, hey, there's no such thing as a free lunch. Overclocking definitely gives you more performance, but it comes at a cost. Pushing more cycles means generating a lot more heat, which means you need some serious cooling to keep it from getting damaged. It can also make your whole system unstable if you pushed it too far, leading to random crashes and errors. So just how far can you push it? Well, with extreme cooling methods, I'm talking liquid nitrogen, professional overclockers have hit some absolutely mind-boggling speeds. The current world record, which was set with an Intel Core i9-1490KF, is an astonishing 9.12 gigahertz. That is over 9 billion heartbeats per second. Okay, so the path forward is pretty clear, right? Just buy the chip with the biggest gigahertz number on the box. Well, it's not quite that simple. This very idea led to what the industry now calls the megahertz myth. So let's do a little thought experiment. Imagine 2 different processors. Maybe they're from different companies, or even just different generations from the same company. Both of them are advertised with the exact same clock rate, 3.0 gigahertz. So which one is faster? I mean, they have the same heartbeat, the same tempo, they've got to be equal in performance, right? Nope, wrong. And this is the absolute core of the megahertz myth. The simple truth is that comparing clock rates between different types of processors is a totally inaccurate way to judge performance. And here's the most crucial point, the one thing you should take away from all this. The clock rate tells you how often a processor works, but it doesn't tell you how much work it actually gets done in that time. It's like having two workers. Both might be working at the same pace, taking one step per second. But if one worker is carrying one box with each step and the other is carrying five, well, you can see who's more efficient. A processor's real performance depends on a bunch of other stuff. The most important is something called IPC, or instructions per cycle. It's literally a measure of how much work a chip does per beat. A modern chip might complete 5 instructions in a single tick, while an older one only completes 2. And then you've got its fundamental design, the architecture, the amount of super-fast memory it has on board, called cache, and of course, the number of cores. All of these play a massive role. You know, for decades, the main way to make computers faster was just turn up the clock rate. But we are really starting to hit the physical limits of that whole approach. Pushing those frequencies higher and higher just generates way too much heat and uses too much power. So the whole industry has had to shift its focus. The goal isn't just a faster heartbeat anymore. It's about making a smarter, more efficient heartbeat that gets more done with every single beat. And this is where we see the new frontiers of CPU design. Instead of just cranking up the speed, engineers are using all these clever techniques to get more work done per cycle. They're designing chips that can work on multiple instructions at once, kind of like an assembly line, and even do instructions out of their original order if it ends up being more efficient. It's all about finding new ways to make sure the processor is always busy doing useful work, pushing the limits of both performance and efficiency. So, the next time you see that big gigahertz number on a box, you'll know it's only one small piece of a much, much bigger story. It's the tempo, sure, but it's the efficiency of the dance that truly matters. And that leaves us with a final thought. As we reach the ceiling of raw clock speed, where is the next great performance leap in computing going to come from?